Good evening, everyone. I'm Shimaika Nakita, and I will be the last reporter for this group, Chapter 25, Fire Protection. This will be the topics that we are going to discuss. Let's start with automatic fire detection, flame stage. The detection in the first two stages is considered as early warning, the incipient and smoldering stage. Actions taken as response to these early warning alarms do not have to be as fast as they be in the next two stages. The third stage is the flame stage, where actual visible fire exists. This is very quickly followed by the fourth stage of heat and the rapid spread of flames. In this stage, the main requirement for detector is speed. At this point, it's about to be too late as the fire can very quickly progress once flames were visible. So we want a detector that's gonna go off as quickly as possible. As I have already said, the response action to these detectors must be very fast in order to suppress fire before it gets out of control. So the devices that are used at this stage are flame detectors. They are usually programmed to respond only to flickering sources like flames. There are two types of flame detectors. The first one are the ultraviolet radiation detectors, and the second one are the infrared radiation detectors. Both of these radiations, the ultraviolet and the infrared radiations, are present at the beginning of the flame stage. And both of these types of detectors are sensitive and fast, which are the key requirements for detectors at this stage. An example that we have here is a combination of UV-IR flame detector. This unit is equipped with a microprocessor that performs diagnostic procedures and ensures proper calibration. So this is much better because it can reduce false alarms. Let's proceed to automatic fire detection heat stage. The heat stage is the last and most hazardous stage because by this time a fire is burning openly and producing great heat, incandescent air, and smoke. Heat or temperature detectors are the devices that are used at this stage. There are two types of heat detectors. The first one are the spot type heat detectors, which are usually mounted in the center of the area that they protect. The second one are the linear heat detectors. In these devices, the entire length of a cable-like element is heat sensitive. Both types respond to high ambient temperatures caused by hot air convection from a fire. So, muna sa examples sang spot type heat detectors kag linear heat detectors. Okay, next. Special types of fire detectors. Several other sophisticated detectors are available for early warning during the incipient and smoldering fire stages. Among the most sensitive is a unit based on the operating principle of a Wilson cloud chamber. This very early warning system detects microscopic combustion products in air aspirated from the protected area using a cloud chamber effect. So, ano na siya ang cloud chamber effect? When microscopic particles such as those produced by the early stages of fire are introduced into a saturated atmosphere or cloud chamber, they act as nuclei around which water vapor condenses to form visible droplets. The detectors operate by continuously sampling air from the protected space and setting off an alarm when the cloud chamber indicates the presence of particulate matter. Next, false alarm mitigation. So, smoke detectors are subject to false alarms due to moisture and particulate matter in the air. Now, how can we avoid this? We have here basic guidelines to minimize false alarms. For those, first we need to select appropriate smoke detectors. Use detectors with drift compensation to permit accommodation of dirt, high temperature, humidity, and air current ambient conditions. Use radio frequency interference or RFI filters. Use control panels and detectors that have self-learning software and multi-space type algorithms. Use detector covers in areas where any type of construction work, is taking place. Ensure a regular maintenance and testing program. For our don'ts, we need to avoid placing detectors in areas where ambient conditions can cause problems. These areas include kitchens, laundries, boiler rooms, shower rooms, and other spaces with high humidity and steam. Repair shops, laboratories, and other areas where open flames are used in normal work. Garages and engine test facilities where exhaust gases are present. Smoking rooms and areas near spaces designated as smoking areas. And areas in which heavy accumulation of dust and dirt can be expected, and areas of high air movement, such as near loading docks and exit doors, and near the discharge from diffusers or registers. Manual stations. So in contrast to automatic detectors, manual stations are operated by hand. Manual stations can serve to spread an alarm that has already been detected by other means, either human or automatic. Manual stations are placed in the normal path of egress, amo na siyang gina-exitan sang taho, so that an alarm may be turned in by a person as he or she exits. So it is imperative that stations be well marked and easily found. Amo siya mostly makita natin sa mga buildings kag nagaka-tempt kita pinduton. Next, sprinkler alarms. The water flow switches are placed in sprinkler pipelines and operate when a sprinkler head goes off. In electrical terms, a water flow switch is a set of contacts similar to a temperature detector. So an example that we have here is a typical water flow indicator. The unit bolts onto a sprinkler pipe with the paddle inside the pipe. Any water motion deflects the paddle, causing a signal to be transmitted from the micro switch mounted in the box on top of the pipe. For audible and visible alarm devices, the type and placement of audible and visible alarms in a public building must meet the requirements of the NFPA 72, the National Fire Alarm and Signaling Code, and the ADA Americans with Disabilities Act. So prepare your ears, marikita the video. So ang sound amo to siya ang aton nga audible signal kag ang naga-flash amo na siyang aton nga visible signal. So this is our manual station. For audible signals, there are several requirements, the most important of which requires a minimum alarm sound pressure level of 15 dBA above the average ambient sound level, or 5 dB decibels above the maximum sound level, whichever is greater for at least 1 minute. For our visible signals, the requirements for these signals, the primary purpose of which is to alert people with hearing impairment. All of the standards require that the visible alarm be a strobe light, usually a xenon flash tube, flashing at less than 2 Hz to minimize problems for persons with photosensitive epilepsy. Strobe intensity. For non-sleeping areas, the ADA requires a strobe intensity of 75 candelas and 50 feet or 15 meters maximum unit spacing, whereas the other standards require an intensity dependent upon the size of the room. For sleeping areas, the same lang naman gyapon sa ADA, whereas the other standards require a 110 CD source if wall-mounted and 177 CD source if ceiling-mounted. Sa corridors, ang mamangyapon ng ADA, still the same, but other standards ang ilang requirement nagavary sa kalabaon sang corridors. Next, General Fire Alarm Recommendation. Specific design decisions must meet the requirements of the latest edition of the NFPA standards plus other codes having jurisdiction. Special attention is directed to Article 760 of the National Electrical Code or the NFPA 70. Sa book, specific design decisions must meet the requirements of the NFPA standards, which is based in US. Here in the Philippines, the DPWH standard specification for fire alarm system are also adapted from the National Fire Alarm Code, the NFPA 72, and also based on the Philippine Electrical Code, called ang Fire Code of the Philippines. Let's proceed to residential fire alarm basics. So residential occupancies that include ang single-family residences, multi-unit complexes, and many-unit apartments. The alarm requirements for such a range of building types vary. So in general, the system should provide sufficient time for the evacuation of residents and in larger buildings for appropriate countermeasures to be initiated. So the elements of the system are the various alarm initiating devices, wiring and control panel, and audible alarm devices. Amo na siya for the residential alarm. For multiple dwelling alarm systems, dara na include sa mga apartment houses, dormitories, hotels, motels, and rooming houses. So, ang prime directive for these structures in the event of fire emergency is early warning and orderly egress or pag-exit, with the consideration of the fact that a fire emergency may occur when most of the building's occupants are asleep. So design guidelines are as follows. Audible or visual alarms must be positioned so that all sleeping persons, including those with hearing and or sight impairment, will be awakened. Also considered the possibility of living rooms being used as sleeping areas on a regular basis. Provide smoke detection in corridors, service spaces, and utility and storage rooms. Battery-powered detectors may not be used because, unlike homeowners, apartment dwellers rely on the building's management for all building services, and periodic battery checks and replacement might not be carried out. Provide standby power to all fire alarm circuits. All alarms should be identifiable either by addressing or annunciation. An alarm light over the door of each apartment or suite to indicate the location of an alarm is desirable. This is particularly important if the central panel only provides zone annunciation. And in high-rise buildings, an emergency voice or alarm communication system should be provided. For commercial and institutional building alarm systems, the requirements for these buildings are so varied that no specific recommendations can be made. A few suggestions, however, are in order. Pre-signaling, where permitted, is recommended for buildings that do not readily tolerate an evacuation alarm. In schools, particularly for the elementary grades, a rapid orderly evacuation of the building is the primary requirement. Consideration must be given to the uniqueness of the sound of the fire alarm gongs para nga wala sang confusion sa mga program gongs. Kag also, because regular fire drills are mandatory in most schools, the system must be arranged to provide this capability. Public buildings should have an auxiliary alarm connection to the fire department. For medium-sized buildings, an accurate cost estimate frequently indicates an advantage of addressable analog systems over addressable systems because of high detector maintenance cost of the latter. Similarly, addressable systems frequently have an economic advantage over hardwired systems because of the high labor costs for wiring. Let's proceed to high-rise office building fire alarm systems. So, sad experience has demonstrated that high-rise buildings once thought to be fireproof are emphatically not so. Indeed, due to their size, they have particularly severe fire protection problems, one of which is reliable communications during fire emergencies. As a result, fire codes now require that high-rise buildings be equipped with an emergency voice or alarm communication system. This system provides full control of transmission and building-wide distributions of all tones, alarm signals, and the voice announcements on a selective or all-call basis. So the distinctive characteristics of the system for the high-rise office building are the communication system, the visual display of alarm locations, and the remote control of air handling equipment. Last, for industrial facility alarms, in addition to manual stations at points of egress, these buildings use temperature and smoke detectors in storage areas and laboratories, smoke and flame detectors in record rooms and continuous process laboratories, and water flow switches on all sprinklers. So this ends my presentation. Thank you very much, and once again, good evening.